Hey guys, I'm back. So sorry about the delay of making videos, and the Hunt for Life episode 6 is delayed because something randomly signed me off of Steam because I had to restart my PC. My graphics wasn't working, so I had to restart my PC and it worked. But I gotta figure out how to sign back in again. Anyway, we're gonna react to the entire history of Earth by me reading it. So, this is the beginning of Earth and the Sun, the solar system, about 4.5 billion years ago. Actually, it's 4.570 billion
More than
years ago.
4.5 billion years ago, the Milky Way galaxy collided with a nearby dwarf galaxy. This encounter hastened the formation of stars. Our solar system is a part of the Milky Way galaxy.
Yeah, that's correct. Well, the early Milky Way galaxy looked a lot different.
Within the solar system, material circulation had been progressing.
Right now, the Sun is a T-Tauri star. The second stage of a star where the
water component
flows
from the outer region evaporated to make materials dry.
with the bipolar flows coming from the north to the south. And right now, they coalesce
Through
into
this process,
asteroids.
particles were zonally distributed, depending on
That's
their
the
water
snow
content. The bipolar flow stopped, and with it, material circulation.
Yeah, the Sun was
Some
very
regions
young.
around the Sun with high particle density appeared.
This is what
Within
it looked like
these
before
regions,
the planets
collisions
formed,
frequently
and the
occurred.
dwarf planet emerged,
Small
or
particles
asteroids.
gradually grew to become planetesimals.
Yeah, planetesimals are small, rocky-like objects with less mass.
Planetesimals continued colliding with smaller particles
right now,
and other
what you're seeing right
planetesimals,
now is
eventually
about
growing
two
to planets,
planetesimals colliding
such as the
to
Earth.
form a planet, which we all know as Earth. This is what Earth looked like when it formed. Yeah, it was an uninhabitable molten lava world.
A number of planets were moving in the same orbit.
That planet right now is named Theia.
The early Earth collided with a smaller, Mars-sized planet.
Yeah, the impact was massive. Yeah, and Earth looks like this after the collision. Just a barely molten lava surface with a temperature of 4,440
Debris from this
Celsius.
impact eventually came to form our moon.
Here is Luna. Okay, I'm
The
saying Luna
Earth-Moon
because
system,
it is
as we know it today, was in
because I have
place.
to pronounce it properly, not the moon. So the second part is about the Archean Eon. So these asteroids are filled with water, and that's why
Countless
water is on the Earth's
planetesimals and
surface.
icy planets bombarded the early dry Earth. Due to the bombarding water-enriched planetesimals, the Earth became enveloped by an ocean atmosphere system.
Yeah, the thick cloud cover. But Earth looked like a gas giant. It's not how it works. And it looked like Jupiter, but early Jupiter. Yeah, the clouds were thousands of kilometers deep. What you're seeing right now is a violent weather storm.
Water vapor in the atmosphere produced rain, forming an ocean.
During
The atmospheric
first
pressure
oceans
gradually
formed.
decreased.
Yeah, the atmospheric pressure was
The
very
carbon
high,
dioxide-rich
even higher than
atmosphere
Venus.
transitioned into a
Right
CO2
today.
ocean, covering the water ocean.
And right now it was from 300 bar
Carbon
to
dioxide
about
also combined with
2
rock
bar.
components and was transported to the bottom of the ocean through weathering and erosion.
The carbonate minerals are yellow.
At this time, the ocean was still toxic with a high salinity and an overabundance
the
of
ocean
metals.
was very acidic.
It was
and
too
green in
toxic
color.
to support life.
the first life formed about 4.1 billion years ago.
Upwelling mantle displaced the oceanic plates above.
Yeah, right now this is the beginning of tectonic plates. Yeah, that giant rift right there is about the continental plate.
Uplift of the plate by mantle convection caused horizontal slippage due to the weight of the plate.
The black part is heavy metal deposits.
This is plate tectonics in action.
Well, the continents are moving right now, but they're very slow, about a millimeter per
The
second.
oceanic plate subducted under the
and
lighter
a few
continental
centimeters
plate.
per year. Yeah, it takes millions of years for them to move about thousands of kilometers.
Weathered sediments neutralized the ultra-acidic ocean.
They're getting dissolved by the magma on that volcano, inside that volcano.
Heavy metals settled out and became fixed as deposits at the mid-ocean ridge.
But the atmosphere color was orange.
These
or
deposits
yellow
were
because
transported through
of the
plate
carbon
tectonics
dioxide
into
in
the deep
atmosphere.
mantle. Gradually, the ocean became a habitable environment.
But it said it was still too toxic.
By 4.2 billion years ago, a liquid core formed in the center of the
liquid core
Earth.
is called the outer core.
Convection
And-
within the
and the
liquid core
convection forms,
created a strong
creating
magnetic
a
field
magnetic
surrounding the Earth.
Yeah, the magnetic field formed about 4 billion years
This
ago.
geomagnetic field shields the
Not
Earth's
4.2
surface from
billion
cosmic
years ago.
rays.
Well, the
The
magnetic
Earth's
field was
surface
kind of small.
was nearing readiness for life.
Because the inner core wasn't formed until 1 billion years ago. So 3 billion years later. Part 3, birth of proto-life.
Could we use your house to trial our
My God,
24-hour
these
bathroom
ads.
upgrade system? We're looking for homeowners.
The early Earth, when the atmosphere prevented sunlight from reaching the surface,
Yeah, the
primitive
surface
life
was
about
very
to emerge
volcanic.
underground, in the cave of a geyser.
Here it looks like. Also, that yellow glowing stuff is called uranium. Yeah, uranium is
Uranium
radioactive.
ore emitted large amounts of radiation, creating a diverse range of materials, and eventually producing the early building blocks of life.
It's called amino acid, and phosphorus and nucleobase collided together to form. Hold on, not yet.
Water boiled and rose up to the surface.
Yeah, the water
and the
was
surface
very
water
hot
flowed
in
back
the geyser. That's
down into
because
the
of the
natural
hot springs.
nuclear reactor. The temperature of the geyser water remained below 100 degrees,
The base salt
protecting
is
the
right
newly
here.
formed biomolecules. The underground environment was reductive, while the surface environment oxidizing. These conditions
the
were
surface was
necessary to
very
synthesize
stormy and
biomolecules.
You can
In
see
the Earth's
Luna.
Hadean eon, tidal forces were much more pronounced than they are today.
Luna cooled down over millions
Even
of years.
lakes had significant ebb and flow of water, creating wet and dry cycles. These wet and dry cycles were one of the most crucial factors in producing the building blocks of life.
The water's drying up. This is fatty acid and ribose. That's a lot of fatty acids.
Fatty acids came together, encasing the proto-life molecules.
Yeah, right now it's like a bubble. Yeah, because it is a bubble.
Polymerization
amino-
progressed under the wet and dry cycles. Eventually, protein-like basic
Oligopeptide.
materials that could act as
Peptide.
catalysts were produced. These molecules circulated between the geyser cave and the surface environment. The interactions of these materials led to more complex biomolecules.
This is proto-RNA, a life-encoding molecule.
Proto-RNA combined with enzyme-like basic materials
Ribozymes.
and evolved into ribozymes, which had the ability to replicate
what you see
themselves.
right now is a ribozyme.
This laid the groundwork for life to reproduce.
Well, about 4 billion years ago, it was the beginning of the Archaea.
Finally,
And you see-
these
and you see
molecules
a
were enclosed
bacteria.
within lipid membranes, forming primitive protocellular life.
Yeah, there might be an infinite. Yeah, I was right. The birth of the first proto-life. There might be an infinite amount of bacteria in oceans.
This was the beginning of life.
Well, people didn't know what that blue was. The whole history of the Earth and life, but for the initial stage of life. What? Wait, what? Oh, right. But
The Earth's plate tectonics, which had begun with the creation of its ocean, eventually destroyed its primordial continent and subsumed it to the deep mantle.
yeah, there weren't any plants on that island.
By 4 billion years ago, the mother continent had disappeared, leaving life on the margins of a fragmented landmass.
What you're seeing right now isn't what it looked like.
Inside the Earth, a dramatic change was about to begin.
Yeah. It was increasing the outer core strength.
The subducted primordial continent descended toward the core mantle boundary.
Yeah, the core mantle boundary is a region between the Earth's mantle and outer core. It has
The
a temperature
wealth of radioactive
6,000
elements in the
degrees.
primordial
Or
continent caused the
maybe
uppermost
7,000
part of the core to melt.
Yeah, the harder core makes the magnetic field stronger. Oh, I can see the iron core.
By 4.2 billion years ago, the newly created liquid outer core was strengthening the Earth's magnetic field, protecting the surface environment against solar winds and cosmic rays. As a result, life could exist on the surface environment.
Yeah. But
This is brown noise. It can smooth out your brain and help quiet thoughts. Super helpful if you have ADHD or tinnitus. Use it to
wait, brown noise? The emergence of the sun-powered life.
The supply of energy and nutrients to maintain
skip a few
resilient
things.
life forms were able to adapt and survive in harsh
This is
environments.
the surface of a bubble. Yeah, those tiny cells are very
This
small.
second stage of proto-life evolved to make use of the sunlight available on the Earth's surface.
I see some oxygen.
They developed a metabolism
it was-
that converted light energy into electrochemical energy. Moreover, they used sugars to store energy for the sunless night
Yeah,
hours.
the amino acid and the sugar combined.
The source of energy for life on Earth shifted from nuclear geysers to the sun.
Wow, the uranium oil is glowing down there. It's glowing very bright. 4.1 billion years ago, mass extinction. But what do you mean? Oh, yeah. The superculture.
Around 4.1 billion years ago, the ocean was still extremely toxic, killing off most of the proto-life forms within it. Nevertheless, some proto-life forms survived the extreme environment.
Okay, guys, I have to go right now. So because I have to make some more studying because school is almost starting. Okay, so I hope you all enjoyed the video, and I'll see you guys in the next video. Bye, guys.